So our second section we're going to look at is 2-4. And it's similar to what we did yesterday. Yesterday we talked about solving equations, getting the variable by itself. But today we're going to solve inequalities. So you know that you're solving an inequality problem when you don't have an equal sign. And in place of the equal sign, we have one of those four symbols. What's the first one? Less than? Less than or equal to? And greater than or equal to. Yep. So you're going to see one of those four symbols in the problem. Okay. There's an example of an inequality. There's two, actually. The one on the left is just a true statement. 3 is less than 8. The one on the right is a conditional inequality. It could be true if you pick the right value for x. Let's see. Okay, but unlike an equation, there's a lot of numbers here that would make this true. Because all you have to do is find 3 times something that's bigger than 12. All right? So, for example, if I plugged in 5, would that be true?
Yeah.
Yeah. If I plugged in 7, would that be true?
Yeah.
Yeah, so lots of answers. If I plugged in 4, would that be true? No. I'd get exactly 12, and 12 is not bigger than 12. All right. So rather than writing our answer with an equal sign in it, because you're doing an inequality, the answer is going to have a symbol like that in it, a greater than or a less than. So for a number to be a solution, it means that you can take that number, plug it back into the variable, and you get a true statement. Okay? And I already did that with a couple numbers with you guys. Okay? We did, like, if you plug in 5, 3 times 5 is 15, and 15 is greater than 12. So 5 is a solution. We did, I think I said 7. You plug in 7. What's 3 times 7 give you? 21. And is that greater than 12? Yeah, so 7 is another solution. And then we did, I think we did 4. And you get 3 times 4 is 12. 12 is bigger than 12? No. So 4 is not a solution. Okay, so any question on how you check if a number is a solution by plugging it back in? Okay, so there's 2 words that come up a lot when we do inequalities. One of them is the word or. And does anybody know the other word that comes up when we're dealing with inequalities besides or? Well, think about in English, which word is a conjunction in English?
2 words put together.
And what's the word that you use in English that is a conjunction? And. Yeah. And. So when we have a conjunction, that's when you have 2 inequalities connected with the word and. All right? So that's an example of a conjunction. X is greater than -1, and x is less than 3. Most of the time when we write a conjunction in math, we shorten it. Okay, this is the long way to write it. 2 separate inequalities. I'm going to show you how you can take those 2 and combine them together. So the way that you can combine them together, one way to do it, is you put the x in the middle, the smaller number on the left, and the bigger number on the right. And both inequalities point to the left. And if you break it down, you can look at it and see both the original inequalities. So this one right here is that part right there. You have a -1 and an x, a -1 and an x, and it's pointing towards the -1. It's pointing towards the -1. Okay, if you look at the second one, you have an x, you have a 3, it's pointing at the x. Up here, an x, a 3, and it was pointing at the x. So what we do is we put the x in the middle and we use it twice. It goes with the part on the left and the part on the right. So essentially what a conjunction is it's an interval. Okay? It means, in this case, if I said to you, like, pick a number that satisfies this, you could pick a number between -1 and 3. Could you include -1 and 3? No, it has to be bigger than -1, and it has to be smaller than 3. So you could pick like 2.99, that'd be fine. So that's what a conjunction is. It's a between two numbers. This particular interval is called an open interval. So we're going to talk about a few different terms to describe intervals. Open versus closed has to do with, is it a greater than or equal to, or is it just a greater than? Or less than or equal to or less than. That determines if it's opened or closed. And then the other thing we're going to talk about is an interval that is bounded versus unbounded. Let's take another one and see if we can combine it together. Let's do, let's say x is greater than 4 and less than or equal to 10. Okay, how would I combine that into one inequality with an x in the middle? Well, what would we start with? I kind of just gave you a hint. You start with x in the middle. Okay. Yep.
They all be facing the same direction.
Okay. So let's figure out, where do you want to put our numbers? Where do you want to put the 4?
Well, the smaller number goes on the left.
Smaller number on the left.
And then it's less than x.
And then it's a less than x because it has to be like the first one.
And
Yep.
x is less than or equal to 10.
Less than or equal to 10. Yep. So that's how you can take two separate inequalities and combine them. Now let's take something like 3 is less than or equal to x, which is less than 12. And let's split it apart. What would be my inequality on the left side? And I'd like to start with the x like that. Yeah.
X is greater than or equal to 3.
Yep. X is greater than or equal to 3.
And then x is less than 12.
And x is less than 12. Okay, so knowing how to take two inequalities and either combine them or split them like that, that's important. Okay, any questions on that? All right, so we're going to look at a few terms now to describe like those kinds of intervals. The first terms we're going to look at are what are called bounded and unbounded.
It's like Lewis's handwriting.
I don't know why, sometimes
Understand that?
it moves a little bit. So the first type of interval we're going to talk about is what's called a bounded interval. Okay, so a bounded interval means that it starts and stops at a number. Well, does anybody remember where an interval could start and stop at that's not a number?
0.
No, 0 is still a number. 0 is still a number. Yeah?
This is a gamut, but infinity?
Infinity,
Okay.
yeah. So when we start talking about putting an infinity in one of these intervals, now we're not talking about bounded anymore, because that goes on forever. Okay, we'll talk about that after. If you can include the number on each end, okay, that is called a closed interval. So remember, when you have a less than or equal to or a greater than or equal to, the way you would describe that as an interval is with the brackets. Okay, I think we talked about the brackets probably last week or the week before. So those mean you can include the number. So when you write an interval like this, that means you can pick numbers between 3 and 10, including the 3 and including the 10. It's equal. Compared to an open interval. That's where, as an inequality, you would see those symbols. And when you write it as an interval, you use parentheses. So parentheses mean you cannot include the numbers. So if I said you can pick a number between 5 and 20, but you can't pick 5 and you can't pick 20, I would use parentheses. So you can go as low as like 5.0000001, and you can go up to 19.9999. But you can't go up to 20. So any question on the difference? You can include the numbers that are right on the end of the interval with closed. With open, you can't. So then the other type of interval is like a half open. So that means you can include the number on one end, but not the other. So you could have an interval that's half open. This one's half open on the right. So you can include A, but not B. And the bottom one, you can include B, but not A. If you wanted to think of it kind of like as a picture on a number line, if here's A, here's B, what kind of circle do we use on a number line when you can include?
Closed.
Yeah, so you could think of it as like closed circle on A. What kind of circle when you can't include it? Open circle on B, shade between. The bottom one, same idea. Can you include the A in the bottom one? No, so use an open circle. Can you include the B in the bottom one?
Yes.
Yep, so it's a filled in circle and shade between. I didn't draw the closed and open, but like the closed one would have a filled in circle on each end. And the open one would have an open circle on each end. So there's really 3 different ways we can describe an answer to an inequality. We're going to use all 3. One way is interval notation. That's what I just circled there. Another way is inequality notation. That's where you use greater thans and less thans. And the third way is a picture, right? Draw it like on a number line. So those are three different ways of describing your answer when you do an inequality. Interval notation, inequality notation, graph. Okay, so these are all bounded intervals. That means it definitely starts somewhere and it stops somewhere. What do you think the opposite of a bounded interval is? Unbounded. So for an unbounded interval, that means that it goes on forever. You're not shading between a starting point and a stopping point because there is no starting or stopping point. It goes on forever. So unbounded intervals, you'd see infinity. So that's examples of interval notation. If I wanted to graph this one in the upper right, I'd have a 5. And what kind of circle would we put on the 5? Open or closed? Closed. And you're shading all numbers that are 5 or higher. So when you shade, you put an arrow. That means it's unbounded. Just, it keeps going. If you wanted to do the one below it, same idea, except what kind of circle would you have on the 5 this time? Yeah, there'd be open circle, shade right. Okay, so there's different kinds of unbounded intervals too. Closed circle, shade right. Open circle, shade right. Closed circle, shade left. Open circle, shade left. You also could have a negative infinity, comma, positive infinity, and then you're shading arrows in both directions. All right, so any question on the difference between bounded versus unbounded? How about open versus closed? Okay. So just different terms we use to describe intervals. Okay, so now we're going to take something that's written as an interval and we're going to change it to inequality notation. So when you're writing something as an inequality, you need to pick a variable. Okay? What would be a good letter we could use for what would be a good letter we could use?
X.
Yeah, we could use, it doesn't really matter, just pick a letter. So we're going to start with an X. And tell me what X has to be greater than in that interval.
That's 5.
Oh no, it's negative.
It has to be greater than -3. And what else? You can't just go, it's not unbounded. It's greater than -3, but it's also
Less than 5. Less than or equal to 5.
less than or equal to 5. Yep. So technically that's fine. You wrote it as an inequality, but let's say it was a multiple choice and they put it all together. What number would be on the left? -3. And on the right? 5. What symbol would we put between the -3 and the x?
Less
You put a less than. And how about between the x and the 5?
Less than or equal to.
Less than or equal to. So both of those are correct. The bottom one is more compact. Okay, so interval notation, inequality notation. Any question on that? All right, let's try this one. -4 to infinity. All right, so let's pick, start with a variable.
X.
Okay, so we're going to say x. And what does this tell me that x has to be?
Greater than or equal to negative.
Yeah, it just tells me that it's greater than or equal to -4. You don't have to say greater than or equal to -4 and less than infinity. I know it's less than infinity. Everything is less than infinity. So you just have to say that it's greater than or equal to -4. So an unbounded interval doesn't have 2 inequality signs in it. It just has 1, and that's it. Any question on that one? All right, so interval notation, inequality notation. And let's try this one. First, what kind of interval is this? Is this bounded or unbounded? It's bounded because it starts at a number, stops at a number. Is it an open interval, closed interval, or half open interval?
Closed.
Yeah, it's closed, completely closed. Yep. Okay, so start with x and tell me what x has to be greater than or equal to.
That's greater than or equal to negative
Greater than or equal to -8. But it also has to be
8.
less than or equal to -3. And you could combine that into a shorter statement, but I'm just going to leave it like that. So that means you could pick a number between -8 and -3. Can you include the -8 and the -3?
Yeah.
Yeah, because it's a closed interval. Yep. Okay, any question on that? All right, so now let's take something that's an inequality and change it to a graph. Okay, so on the test, you already have a number line set up, and there'll be different tools you can click. Right, might have boxes like this. One will be like an open circle right, filled in circle right, open left, closed left. So you'll just click on which tool you want to use, and then you'll click on the number line where you want to put the arrow. Okay, so what kind of circle do we need on this one? Closed on what number? 2. And which way do I shade? To the right, right? Everything that's greater than or equal to 2. So shade to the right. Is that an unbounded or bounded interval? That's unbounded because there's an arrow. It just keeps going forever. It never stops. It's unbounded. Yep. So inequality, graph. All right, let's try this one. X is less than 5. Again, number line will already be set up for you. What kind of circle do I need this time? Open on what number? Open on 5. Okay. And how about Felicity? Which way am I going to shade?
To the left.
Yep, I'm going to shade to the left. Perfect. And that is again an example of an unbounded interval. All right, let's try this one. This one is a conjunction. Okay. When you have a conjunction, the word and is hidden in that format. Okay. You just have to know when you read it, that's how you read it. X is greater than or equal to -1, and x is less than 3. All right, so let's set that up. Okay, and tell me my first step to graph that one. Lewis?
Put a closed circle on -1.
Put a closed circle on -1, yes.
And then you would do an open circle on 3.
Oh, on 3, yep.
Then shade between.
And shade between. Perfect. Okay, is that bounded or unbounded? What is it?
Bounded.
Yeah, that is bounded because it starts and stops at a number. There's no arrow. Open, closed, or half open?
Half open.
Half open. Half open on the right. Yep. Okay. Any question on that one? All right. So that's how we can represent our answers when we solve an inequality. Intervals, graphing, or using the less than and greater than sign, which is an inequality. So now we know how to write our answer, but how do we solve it? Well, when we solve an inequality, it's pretty much the same steps as solving an equation, except if you do one thing. If you multiply or divide by a certain kind of number, we have to do something. Does anybody remember when you're solving an inequality, if you multiply or divide by a negative, what do you have to do?
Switch the sign.
Right. Yep, you have to flip the sign. And so if you multiply or divide by a negative, you've got to flip the sign. Okay, not if you do adding, not if you do subtracting, just multiplying and dividing. So let's try, see if we can solve that. So that's 3, and then in parentheses, x minus 1, close parenthesis, plus 2 is less than or equal to 5x plus 6. Okay, Shane, what would be my first step on the left side?
Distribute.
Yep, and what are we distributing?
The 3
The
into
3.
the x minus 1.
Yep, so it's going to give me 3x minus 3 plus 2. Okay, so that's our distributing. Chad, what else can I still do on the left?
You can combine the -3 and the 2.
Yep, and negative 3 plus 2 gives me,
-1.
so negative 1. Okay, so we got that. Well, Dylan, what would I do next?
Now you put the 1 over to like plus the 1 over on the other side.
Okay, we could plus the 1 over to that side, and that's gone. And what else can I do at the same time?
You can minus the 5x with 3x.
Yep, so minus the 5x. And he had a few choices at that step, but putting everything on the left is a good way to do it, because generally when you write your answer, you want the letter, then you want the symbol, then you want the number. So like x less than 5. That's generally the order you want to put it in. Okay, so 3x minus 5x. Now, I haven't done any multiplying or dividing in this problem yet by a negative. Okay, so I haven't had to flip anything. What's going to be my next step? Yep.
Divide by negative.
Right, I'm going to divide by -2. Because I divided by a negative, what do I have to remember to do? Yep, flip the sign. So I would do that right away. So flip the sign. X is by itself on the left. And on the right, I would just leave it as -7/2. Okay, and the way that I wrote my answer there, is that an integral, an inequality, or a graph?
Inequality.
That's an inequality. And it's fine. They didn't say how to solve, like how to write your final answer. So I would just leave it like that. Okay. Any questions on that one? So let's look at how we can solve a problem just like that. But this time we're going to do it on the graphing calculator. And when I show you how to do it on the calculator, there's going to be 2 different ways. Okay, so the first way is we're going to get everything on one side and we're going to get 0 on the other. Kind of like when you're solving a quadratic. You get 0 on one side. Once we get everything on one side, then we're going to calculate a root. So that's second calc root, or second calc 0. I think it's option 2 on the calculator. Yep, option 2. And then the answer is either going to be everything above the root or everything below the root. It depends if the question was a greater than 0 or a less than 0. We'll have to look at the question when we get it. So let's solve that one. Now, this isn't one that you would need the calculator for. I could solve this faster without the calculator, just by adding 1 to both sides and dividing by 4. Done. So if you do that, you'd have x is less than 3/4. Add 1, divide by 4. But you might get an inequality that's not as easy to solve, and you might need to use the calculator to figure it out. So let me show you how you do it. So the first step, get 0 on one side of the inequality. Okay, so what would I do to get 0 on the right? Yeah.
Subtract 2.
Okay, subtract the 2. So this is different than how we would solve it algebraically, but we're not solving it algebraically. I'm trying to show you how to do it on the calculator. So the 2's gone, and we get 4x minus 3 is less than 0. Okay, now type in what's on the left side. 4x minus 3. Right, and to reset the window, if it's somebody changed the zoom, we're going to press zoom 6. And there's our graph. The last thing it says to do is to calculate the root. So remember, to get that, you're going to press second calc, and then it's option 2. And it's going to ask you 3 questions. You've got to pick a point to the left, which in this case means where the y value is negative. Hit enter. Pick a point to the right of where it crosses, which in this case means the y value is positive. And the last thing is the guess. Just put that kind of close to where you think it crosses. And if you did it right, it should come up and say x is 0.75. Any question on how I got the 0.75? All right, now this is an inequality, so my answer is not going to have an equals in it. It's going to have a 0.75, but I need to figure out what part of the line I'm looking at. In this, do they want to know where the line that I drew in blue is above 0 or below 0? Below 0. That means they want me to figure out this part of the line. Where on the x-axis would you go to be on that part of the line? Would you plug in numbers above 0.75, or would you plug in numbers below?
Below.
Below, yeah. If you plug in like 0, you're down here. If you plug in -1, you're way down here. That's the part we want to be on. So the answer is all numbers below that point, and that point is 0.75. So it's everything under 0.75. If this said, where is this greater than 0, then that means I would have been on the other part of the line, and I have to plug in numbers above 0.75. And that would put me above 0. So is there any question how we got the 0.75, or why we put a less than right there? Okay. So that's one way you can solve an inequality on the calculator. Get 0 on one side. Okay. Second method. This method, you don't rearrange it. You don't have to get 0 on one side. So I'm going to do the same inequality that we just did again. But this time, leave what's on the left, and leave what was on the right. Put both of them in on the calculator. So let's put in 4x minus 1, and then put in 2. Okay, I did 4x minus 1 in blue, and I did the 2 in red. So that one's red, that one's blue. So if you want to think of it like in terms of the color, I'm going to be looking for where the blue one is less than the red one. That's what I'm looking for. So let's hit graph. This time you're not going to calculate a 0. You're going to calculate something else. What do you think you're going to calculate this time? Yep. Where they intersect. Yep. So now I'm going to calculate an intersect. And then the last step is the same. Once you know where they cross, do you want all the answers under that, or do you want all the answers above that? Well, you have to look back at the original question. Okay, well, let's do the intersect. Second calc, intersect is option 5. Remember, this is the same question I just did before, so we're going to get the same answer, but I'm just showing you how to do it this way. Pick a point on the blue, pick a point on the red, and do your guess. And it says they cross when x is 0.75. So just put that up there. Now, we are looking for where the blue one is under the red one. That is this section going on forever that way. So what kind of x values would I have to pick so that the blue line is under the red line. Would I want to pick x values below where I just circled or above? Below. Yeah, we have to pick x values below that. If you pick an x value above it, like if you pick 2, well at 2 you're right there on the red one, and you're there on the blue one when x is 2. That's not what you want. You want the blue one to be under the red one. So 0.75 below. Not below or equal to, because the original problem didn't have an equal to. Okay, so there's 2 different ways you can solve inequalities. It doesn't matter which way you do it. Do whichever way you think is easier. Okay, so any questions on either method 1 or method 2? Okay, so example 5, I already did it. That was just solving it graphically again. Okay, so yesterday, towards the end, the last thing we did was solving absolute value equations. That's what we're getting towards finishing up here. We're going to be solving absolute value inequalities. When we solve absolute value inequalities, it's going to end up splitting into 2 problems. So to kind of warm up and get ready for that, I'm going to show you a problem that's a little easier than absolute value, but it splits into 2. And then we'll do absolute value. So this is called a double inequality, or it's a conjunction, like we did earlier. And the way that we're going to solve this is split it into 2 problems. Like, there's different ways you can solve it. You can do it a different way, but that way doesn't work all the time. So I'm going to show you this method. So you're going to split it into 2 problems. And then solve. Okay, I'm not going to do that one. That's just an example of a double inequality. I'm going to do this one. So when you split it into 2 problems, this in the black box, that'll be one problem. And what's in the blue, that'll be my second problem. And when we split something up like that, we're going to have a certain word between the 2 answers. This is the short way. We're going to make it the long way. What's the word that goes in the middle?
And.
And. Yep. So we're going to put the word and. So let's put that. And my first inequality is -3 is less than 2x plus 5 over 3. And what's my second inequality?
Is it just 2x plus 5 over 3 is less than or equal to 5?
Yep. Okay, and now just solve each one. Okay, so first thing we want to clear that denominator by getting rid of the 3. What would you do on each side to get rid of that 3 in the bottom? Yep. Now, do I need to flip the sign here because I multiplied and I'm multiplying and that's a -3? Did I multiply each side by a -3? No, that -3 was just on the left side. I multiplied by +3. So don't flip anything. So that's gone. Okay, so we get that. What's my next step? Minus the 5. -9 minus 5 is going to give me -14. Last step. divide by 2. And that's a positive 2, so you don't need to flip anything. Negative 7 is less than x. It's okay to write your answer like that. I'd prefer it like this, but it's not wrong. All right, so we get that. And we're going to do the exact steps we did on the left to do the one on the right. So what was my first step? Multiply by 3. So the 3's gone. And multiply the 5 by 3. 15. Okay, next step that we did over here, same step we're going to do over there. Minus the 5. That's gone. And the last step here, same as the last step there. Divide by 2. Yep. So divide each side by 2. And again, that's a positive 2, so you're not flipping anything. Okay. So x is greater than negative 7, and x is less than or equal to 5. All right, so that's a problem where you had to split it into 2 to solve. Okay. Any question on that? Okay, so the last topic is still splitting it into 2, but this time you have to figure out 2, and it's kind of like we did yesterday. In fact, the steps are pretty much the same. First thing is, you've got to make sure the absolute value is by itself. I think most of the ones I give you, the absolute value is already by itself on one side. Once you get it by itself, then we're going to split it up. Okay, the first inequality is exactly the same as the step I gave you yesterday for an equation. Just copy down the problem without the bars. Yeah, just put that on my desk, thanks. So the first inequality is exactly the same as the problem I give you, just don't copy down the bars. Remove the bars. Now yesterday when we did the second equation, we got rid of the bars, but what else did we have to do to get the second equation? So yesterday when we split absolute value equations up, the first one we got rid of the bars, but the second one we got rid of the bars and we did something else.
You flip the sign on the end.
Yeah, we changed the number on the other side, made it the opposite. And that's pretty much what you have to do today. You're going to get rid of the bars. You're going to change the sign of the number that's on the other side. But that's the extra step. You also have to flip the sign. So for the second inequality, you do 3 things. Get rid of the bars, flip the sign, and change the number on the other side to its opposite. And yesterday, the final answer always had the word or. Today we have a choice. It could be and. The other option is or. We can't put the wrong one. We have to make sure we put the right word, and I'm going to show you how you know which word to put. When you look at the original problem, if the original problem has any kind of a less than symbol, less than or equal to, the final answer needs to have the word and in it. What do you think the 2 symbols are that you would use the word or for? Right, and the way I remember that is I pronounce it, instead of saying like greater, I pronounce it as greator. Okay, think of it as like it's a greator or equal. If you say it as greator, you'll remember greater is an or. That's how I remember it. So less than is the and, greater is an or. All right, so we'll try one of those, and then that'll be the last one for today. But if you can solve an inequality, if you can solve an equation, inequality is pretty much the same thing. Just so there's not so many 3s to confuse people, make that a 4. Okay, so first step, isolate the absolute value. Is the absolute value by itself? Yep, it already is. So we're going to split this up into 2 problems, and once we split it, then it's going to be just like what I showed you with the double inequality. You'll have 2 things to solve. What's the first inequality that's going to split up into? Yep.
X minus 3 is less than 4.
Less than 4. So we got rid of the bars. Now when you do this one, you got to remember to do 3 things. Bars, flip, opposite number. Yeah, were you going to go ahead and tell me that?
You flip X. So you flip the side, and then you don't flip the side.
Well, you're going to change the sign of the number on the other side.
Yeah.
Yeah.
Okay, so X minus 3, and then flip the sign, and then negative 4.
Exactly. So took out the bars, he flipped the sign, and made the number negative. You just have to remember those 3 things. Now, each one of these just has 1 step to get X alone. What's our only step? Yeah, add 3. What does that give me then for that first inequality? Yeah. X is less than 7. And the second inequality, you do the same steps again. Just like I showed you before, it's the same steps on each problem. What do we get when we solve that one? X is greater than negative 1. And the word that goes between them. It's either and, or it's going to be or.
Is it and?
It's an and. Because the original problem has a less than. Less than is an and. Yep. That's it. So probably not a ton of stuff new, maybe just with calculating the intersect and the root for an inequality. Even that, I think we've done that before. Let me hold on, double check.
We would have been more time in 5 minutes.
Even my gum back.
So I'm just gonna skip 49. And that's it. Okay, so that's the homework on 108. I did take out 49, so make sure if you're looking at the video, don't do that.